Good evening, everybody. Greetings from the great state of New Jersey, otherwise known as the Garden State. And we have a real treat for you tonight. We have Matt Raible and Josh Long here with us tonight, and I think we're going to have a real fun meeting. You may recall, if you've been around with us for a while, that Josh delivered our first talk in October of last year as the newly branded Garden State Java group. And then Matt was with us in person in July of 2019. So it's great to have them together for this talk tonight. But first, as we always do, we'll just take a couple of quick minutes to go through our usual slides, to introduce our sponsors, talk about what's new, and it's a bit of a list tonight. Of course, I'll introduce Matt and Josh, and we are going to have our Intellij idea giveaway tonight. Look for a URL in the chat in YouTube about halfway through the meeting or so to register yourself to be in the lottery for that. Our platinum sponsor is JFrog, of course, and we appreciate everything they've done for us all year as a first-year sponsor. Our platinum sponsor, that is, and Ari Waller, who's head of developer relations. He's been on our meetings a few times this year to give away extra things from JFrog, and we appreciate their support.
Mike, do you want to be sharing slides now?
Oh, I thought I was. Oh, I keep doing that. The joys of being live. Okay, sorry about that, folks. Let's do that again. Okay. All right, so let me show you the platinum sponsor logo. Azul actually joined us earlier this year as a silver sponsor, and of course they have their downstream distribution of OpenJDK that they provide for the Java community. We are partnered with DevNexus. The next conference is April of next year. The call for papers, I believe, has already closed. And as anybody who's been to this conference knows, that this is actually an awesome conference. So we are happy to be partners with them. And, we help them in some of the things that they do. And we have per meeting sponsors, namely JetBrains, of course, that provide the 1-year license of Intellij IDEA. And then, of course, Eclipse Foundation and Jakarta EE, they provide Crowdcast, full version of Crowdcast for meetings, but we've obviously been doing YouTube the last few months, but they're there for us as well. All right, so what's new? Microprofile 5 has been released last week, the same day as the Jakarta 1 conference last Tuesday. Jakarta EE10 had an original release date of the first quarter of next year. However, that's been delayed to the second quarter. And of course, the biggest news is the Log4 shell vulnerability, which was all over the place, in Twitter, on news organizations. Even CNN.com had a news piece on it as well. So, I'm sure you've seen some of the, I think Spring Boot put something out for that, Josh. It would only affect users if they are using Log4j as their default logging. With regards to JDK, JDK 18 is in ramp down phase 1, and that means the feature set is frozen for the release in March of next year. There are 9 features. You can check out my latest Java News Roundup that has that information in there on all those JEPs that will be part of JDK 18. And also the JDK 19 expert group was formed basically with the same folks, Brian Getz and only about 4 or 5 others. I believe Simon Ritter is one of them as well. So start looking for information on that, early access bills and things of that nature. I've kept this on here the last few months just to get the awareness out. We do have a Meetup page. We just opened it up maybe 2-3 months ago, if that, and you can check out the latest information there as well, along with our website. And then, being a member of the Jakarta EE ambassadors. We have a JCAT, Jakarta community acceptance testing that's extended through the end of the year. This is your chance to play around with the framework and provide any feedback on things that you may have noticed. Okay, so here we are, Matt and Josh. Matt works for Okta as a developer advocate, and Josh Long is also a developer advocate for Spring at VMware. So without further ado, I will stop sharing, let them introduce themselves, and away we go.
Well, hi, thanks for that. I appreciate the warm welcome. Good to be back. And there's Matt. That's
Here I am. We're not together this time, unfortunately, but we're together in our hearts.
Yeah, in our hearts, and that's what matters. Yeah. So thanks for reminding people about the log4j thing. That there was no reason that today had to get worse, but you found a way, and I appreciate that. No, so by the way, if you're using Spring Boot, you're not affected by default, so don't freak out. There's no, by default, you're not using log4j if you're using Spring Boot. So, and if you are specifically opting into log4j, then don't do that, right? Like, or upgrade to the new version, right? There's been a new release that's updated to reflect that. So,
but there's a new development today. You didn't hear logback has a vulnerability.
What does?
But logback.
Really cool.
Which
Good.
Spring Boot does use by default, but
yeah,
you're only vulnerable if people can get write access to your logging file to like modify it, something like that. So it's still kind of out there,
What can they do? Is it like, can they root the computer or like?
It's the same Jindy lookup kind of stuff.
This is let's just not log. I'm just done. Tired of it.
So yeah, they actually put out a new release today and said they've turned off like Jindy lookup and JDBC access. Like they've just said, that's not a good idea. Don't log to those.
I don't even know that was there. It's kind of cool that it exists, but it's obviously fraught.
Right.
Anyway, it's fun. So okay, good. My name's Josh. I work on the Spring team, and this is the one, the only, the amazing, the inimitable Matt Raible. Hold on, let me see if I got this. A hick from the sticks. Is that right?
That's correct.
Right. So so-called, self-claimed hick from the sticks. And we're going to talk about Spring Native and the new stuff, which is really new. So new, in fact, that it's going to cause us a little bit of heartburn. But there's more upside than downside, but there's still some downside. Is that fair?
Well, I don't think it caused you any heartburn, right? Just me when I tried to get this this JHipster stuff working. But I also think, one of the unique things about it, what we experienced was like a lot of times it just fails fast, right? Like on the compilation, it's like, hey, I can't find this class or whatever, so you can go out a type hint for it. But what we've experienced a lot with JHipster as well is the runtime failures, right? Which that's painful because you spend 5 minutes waiting for it to build and then you try it and then boom, it blows up and you're like, you got to do that again.
So we've been trying to move JHipster to Spring Boot 2.6 and to Spring Native 0.11x. So there's been mixed signals about where things are going wrong. But anyway, okay. So Matt and I are gonna look at Spring Native here. I'll kick the ball. I'll kick it off. I'll kick the ball down the road. I'll get us going. I don't know, whatever. We'll start here. Can you all see my screen? Is that font large enough?
Yeah.
Just pretend. Okay. All right. So good stuff. So Spring Native is a brand new project that has been around for actually the first releases of Spring Native. I started talking about it back in March of 2020. It's just been one of those days. March of 2020. So right as the pandemic descended, that was fine because I had a lot more time indoors. And at the same time, I started really kicking the tires on this GraalVM and Spring Native stuff, which turned out to be fairly convenient because GraalVM takes a lot of time. GraalVM is a just-in-time compiler replacement. It's intended to replace the Hotspot just-in-time compiler. And Hotspot is a long serving, old in the tooth piece of code that does some amazing things that makes Java really impressive, right? What it does is it takes successively, frequently accessed code paths and turns it into native code. This has worked well, and it's to the point now where it's common knowledge that you can take a Java application with its garbage collector and its just-in-time compiler and deploy it and actually achieve, in some cases, performance that's on par or better than a similarly well-written C or C++ program, because those programs are often dealing with hiccups in memory, bursts of memory, right? They have to write code in terms of resource initialization as acquisition. So their memory usage looks it's a lot of like create memory and then dispose of it, create memory and dispose of it, right? Whereas with Java, we have a bird's eye view of the whole program, the whole picture. And so we can actually clean all of the memory at once when we need to, and then we don't have to worry about it until it's needed. So because it makes our code cleaner, it makes our performance faster, it's actually a really amazing piece of technology. That said, it got to be a little long in the tooth, and they wanted to update it and replace it with something that was mostly written in Java. And that was the original sort of core conceit of GraalVM. But somebody, I'm sure, said, what if they could take that thing that takes your Java code and turns it into native architecture-specific binary code? What if that thing that we used for adaptively taking Java code at runtime and turning it into native code, what if we took that and just did that proactively for the whole application? And that's the AOT compiler. That's the GraalVM native image compiler. And the GraalVM native image compiler is amazing. What it does is that at compile time, it looks at your application and determines which things are reachable at compile time. So reachable in this case means the compiler can find where it's being used. And it keeps those things, and it throws everything else, including the bits in the JRE that you're not using, including the bits in your class path libraries that you're not using. It throws everything else out the window and keeps only that, and it turns that into a native image, which is great in theory. The problem is that Java is, for all of its sort of stodgy syntax and 25 years of cruft, while it feels a bit like something like C++ and C to some, it's actually got a lot more in common with the likes of Lua and Tickle and Perl and PHP and Python and Ruby and these languages, right? It's a very, very dynamic language. You can take a string, a Java string variable with the contents of a class in it, a class definition written, class foo, curly bracket, whatever. You can take that string, compile it into a .class file, load that class file into the class loader, create a new instance of that type using Java reflection, create a JDK proxy of that type using JDK proxies, serialize instances of that type to disk, and then read them into memory again on some other node and some other virtual machine, all without ever having a single reachable type. And this is a bit of a problem because GraalVM doesn't know about any of that, right? What I just described to you, by the way, is basically eval. If you've ever used any other language ever, you've got something called eval, where you can take a string buffer and it'll turn it into executable code. No vulnerabilities there, of course. So we can do that in Java, and that's an amazing thing. It makes Java very dynamic, and it's amazing. It's one of the reasons that Java is so productive. But the problem is that GraalVM doesn't know about any of that. It tries to throw away all the code that would be required to support such things at runtime. So we have to provide configuration. We call those hints in the Spring Native world, configuration that you feed into the GraalVM compiler to teach it about all the things that you're going to do that might be surprising or unknowable at compile time. These hints, GraalVM supports these configuration hints through JSON files, supporting things like reflection, proxies, serialization, loading resources. Like if you load an image from a .jar, you load something from the class path as a resource, that itself is also a problem, right? So lots of things you have to provide configuration for. Well, as you start building applications, these applications depend on libraries. Increasingly, those libraries are shipping configuration files that give you the hints that get fed into the GraalVM compiler for those particular libraries. That's not all libraries, certainly, but it's a growing portion of the ecosystem, certainly. And so you do well, not just for security purposes, but for the benefit of taking advantage of GraalVM to use the latest and greatest versions of these libraries, because they now ship these hints that get fed into the GraalVM compiler. So part of what we're doing with Spring Native is, we have a tool chain that plugs in configuration so that your typical Spring Boot application works well when you compile it into a native image. And also as part of what we're doing, because Spring, by its very nature, is sort of at the center of all these other different libraries, right? It's the largest ecosystem out there by far. So we have a lot of different libraries where we're trying to make that work in a kind of holistic, clean way for users of the Spring Boot framework and so on. And so part of this, we're actually feeding back information and hints and all that stuff to these other projects. But getting back to Spring Boot itself, and Spring is a component model, right? And Spring does some things that you can't put in a static JSON file. You can't know at the time that you write that JSON file that that Matt is going to write some code tomorrow that'll have a particular type that also needs to be proxied, right? So you need to have a programmatic component model as well. And that's where Spring Native also comes into play. So with that as the backdrop, let's go ahead and take a look at just a very basic application here. I'm going to create an application called Customers. We're going to use the latest and greatest version of Spring Boot 2.6.1. We're going to use Java or Groovy or Kotlin, doesn't all that much matter. And most importantly, we're going to use Java 17. You could use Java 11 or 8, but you would be wrong to do so in every context, regardless of what your motive, intent, or circumstances are. It's not appropriate to use 8 or 11 ever, period. Right? It's a choice that you could make, but that you should absolutely never make, ever. It's a non-choice. Non is not just an Indian bread, my friends. It's a thing that you should not do in any circumstance. Java 17 is faster, more robust, more secure, more performant, more syntax rich, more operations friendly than Java 11 and Java 8 in every single way. If you judge Java 17 strictly just by the number of releases since Java 8, then it is by that measure at least twice as good as Java 8. In fact, one more, right? It's amazing. So I would definitely use Java 11 as Java 17. And you can do that now because GraalVM just recently shipped support for Java 17, which we also support. So with that here done, I'm going to add H2. I'll add R2DBC. R2DBC is a reactive relational database connectivity abstraction. Think of it like JDBC, but it's a different SPI, and it supports really, really high scale concurrency, asynchronous non-blocking IO. And then we're going to create a reactive web application. And I think that's it. That's a pretty trivial little example. I'll hit generate and we'll open this up. And, I'm goosing the numbers here a little bit. Obviously, using the reactive runtime it's to your advantage. It's fast, regardless of whether you're using Spring Native or not. What is this? Do I want to update this right now in the middle of an
oh, yeah, you got to do it.
Okay, done. Absolutely. Okay, so let me see. That font looks a little small though. 20. That's a little large. 18. How's that? You think that'll be okay?
Yeah, that's what I do.
Okay, good stuff. So we're gonna create an application here, and it's just gonna be an application that has data in a database. Data whose records I'll describe using Java 17 record types. And obviously, this is a primary key. I'll signal as much by using that annotation. I'm going to create a customer repository. Repository will handle the tedious, soul-annihilatingly boring read, write, update, and delete lifecycle management. And then I'll create an HTTP endpoint. So, just a functional HTTP endpoint routes, return route. Come on, you got this. Yes. Okay, .build. So .get customers, voila. Okay. New handler function, server response that okay. So all I'm doing is just creating a simple handler. I want to, we'll have something that gets invoked and produces a response, etc. So the other thing is I am creating an H2 application, right? So I need to actually have some data in the database. So I'm going to do that here by going to my resources folder, and we'll create a new file here called schema.sql, create table, customer ID, serial, primary key, name, varchar 255, not null. All right, and we need some sample data as well. So we'll create a new file here called data.sql, insert into customer name values. And let's see, we got Matt, of course, we've got Josh, and we've got other Spring folks as well, right? Whatever, Dr. Sire. Right. Okay. And
The guy who helped us yesterday,
oh, Steve.
right?
Yeah.
Eisenberg? Yeah.
Yeah, it's great too. Okay, but I can't leave it at 9, dude. That's not great. We need the. There we go. Whatever. Okay. So there's my little application. Let's just run this and see what we get. Make sure it works on the JRE. Localhost, customers, and voila. Okay, it's good. There we are. We're happy for you. Our 10 records. So that's working. Now I want to turn that into a native application. To do that, you need to have GraalVM installed. So obviously you can do SDK. If you've ever used SDK Man, which is a great little project here, you can say SDK, and let me see, list Java, and that'll show you, oh, I don't know, all the Javas, right? And there's a lot, right? This is the blessing of our community. Look at that. So I've got this GraalVM. I've said, I've already done this before, but I'll show you what I would have said. SDK install Java, blah, right? And then you can also do SDK default Java, right? Like that one. Once you've done that, you also need to do GU install native image, and that's the native image component inside of the GraalVM sort of ecosystem. It's not installed by default, which I wonder if that's a reflection of sort of the production readiness of it. I don't know, but I don't know why it's not installed by default. It works really nicely. It's pretty good for lots of workloads, Okay, so we've got this here, and I would mention that if it's not installed, right, if you just have a regular JDK, you just get like a weird stack trace from Maven that doesn't really tell you anything. So I've actually been in the process of like entering an issue on Spring Native and then realized that, oh, I'm not using Graal. So just be aware of that. Make sure and check your version. Yes. So here's my RTB. This is the application that we built on the Spring Initializer. It's 60, speaking of Maven, it's 60 lines of XML. Obviously in Gradle, it's like 1 line of code, but there's no Spring Native. And so in order to take advantage of Spring Native, I need to add the Spring Native experimental, it's important, support, right? And so we're gonna copy this same configuration, paste that in here, and you can see it balloons to 158 lines of XML, which is still 1 line in Gradle, just somehow the entire build is just 1 line. And this is a setup for you such that you get the build pack support, which we'll talk about in a second. You get the AOT Maven plugin. This plugin is a clearinghouse for transformations that we can do on the source code before it gets fed into your GraalVM compiler. We have the milestone and release repositories required to source the Spring Native dependencies, and we set up a Maven profile so you can do -P native, and then you can compile a GraalVM image, right? And this is the native Maven plugin from GraalVM itself, fully configured. So all those help you work with GraalVM out of the box. We're going to use the native profile for most of our demos here. But that said, if you want to, most of the time, for a lot of us, we want to take our applications to production. These days, as often as not, production is some sort of OCI image or Docker container deployed into some cloud orchestrator somewhere. So you would say Maven Spring Boot build-image, and that would actually use build packs. That's this thing right here. It would create build packs. It would use build packs, which is a cloud native computing foundation project, to create a container of your application. But since our application is using Spring Native, it'll actually create a Docker image that has the GraalVM binary inside of it. So it'll compile the GraalVM binary inside of a Docker image, and then that Docker image will get put into a container, which will, you can then Docker tag and Docker publish and all that stuff. So even though I'm going to be building a Mac OS specific binary for most of my demos, when you use the build pack support, you get a Linux binary built inside of a Linux Docker image that you can then Docker run, Docker whatever, anywhere, and you can deploy to Kubernetes or what have you, right? So this will automatically take advantage of Spring Native if it's configured, right? If you have Spring Native on the class path like we do here. Okay, so we've got Spring Native, we've got the GraalVM support. We have this AOT framework. Like I said, this is where all of the magic happens. This is where we do work on the code base before we feed it into GraalVM. So let's just kick off the build and talk about what's happening here. Maven native, okay. We can also run the tests. If you run the tests, they get compiled into a native image, and then those get run in the native image. So it takes a long time because you have to compile the native tests, and then you compile the native code. So your build typically takes twice as long in this case. For our purposes, since we are very short on time, I am just going to skip those tests. But it's a useful thing to know. But keep in mind, Mockito does not work at all right now in native tests. Work's being done, it's just not there yet. Okay. So this will take, I don't know, we're actually screencasting. Anybody who's done Zoom presentations knows that the time it takes to do X is now like double when you're Zooming, because there's, I don't know, it takes a lot of CPU resources. I have shut down Slack, right? I'm not running Slack. There's no Slack on my machine anywhere. And that's a good thing, because this process takes a lot of memory, right? And Slack would have taken all the rest of it. So it's actually, do we have numbers yet? It doesn't have the numbers yet, but this takes, 8 gigabytes of RAM, that kind of thing, just to compile this. And there's a reason. It's not just compiling my 3 little types here, right? My tiny little program up here. It's actually compiling all the .class files on the class path. It's doing analysis on all of those, and then creating an image out of that, right? So it's compiling everything on the class path. So by definition, it's going to take a little while longer. That AOT plugin has already kicked in. It's already run. And what it's done is taken our application and built up a sort of meta model about it, and allowed different implementations, different processors, different filters, different whatever, to analyze that meta model and contribute hints where appropriate. Now, if you're just creating an object and you're creating a Spring Bean, and that object is the return value of that Spring Bean, nothing is required from you, right? That should just work just fine. It's where you do things that Spring can't possibly surmise, right? So for example, were I to create a bean that implements a given type, but that bean is actually a proxy, well, you need to tell GraalVM that that's a proxy, and you can do that by telling Spring Native using a proxy hint, and we'll look at all that stuff in just a second, right? But you got to be aware that for 80% of the use cases, it should just work. It's where you do things that are a little bizarre, and where the Spring ecosystem does things that are a little bizarre, right? And we're working to close that gap, but there are, to be fair, gaps. So customers, there's my application, 69 milliseconds, 69 1,000ths of a second, 70 1,000ths of a second, that kind of thing. So there's my application. Let's see if we localhost customers and voila, okay? So this application is useful for its startup time, I suppose, if that's something you care about. But what I love about this is the resident memory footprint. So grep customers, not customers. Okay, and that's this. This is the PID of the application, rss.sh, voila. So it's taking 70 megs or 70 megs of RAM to run that application, right? And that can run in a Docker image using Alpine Linux. So you don't need the full like Ubuntu or something like that. You can use a minimal operating system because there's no JRE. There's nothing else besides that binary. It's all built into that binary. And obviously that's a good thing, TM. So there you go. We've got a trivial application up and running. Like I said, I use reactive, that kind of gooses the numbers, but even, as we'll see in just a minute, even more traditional workloads using JPA and Tomcat and that kind of thing still start up in 150 milliseconds or something like that. Okay, so let's see what that did. Well, I mentioned that there's an AOT Maven plugin. That AOT Maven plugin kicks in, and you can actually use that AOT plugin to kind of pre-flight, not 100%, but a lot of the way. You can pre-flight what is going to happen when you compile your native image. You can see it takes a long time to run those compilations, right? In this case, it takes about a minute and a half. Actually, how long did it take? We can check. It took 1 minute and 51 seconds here. And I suspect that a large part of that is because we're on Zoom. But when I started doing these Spring Native videos way back in March of 2020, not 2010, those videos would, the demo, the compilation would take like 10 minutes, right? So the fact that we've gone from there to this in that short of time, and we have still a lot of room for improvement. Oh yeah, life is good. Okay, so you would run this. You'd say Maven clean package Spring AOT generate, and what that'll do is it'll kick off the AOT plugin without forwarding it all the way down to the GraalVM compiler, and then you can see some of what's been done here. You can see that first of all, we have an AOT package in there that's been generated in the generated source code folder, and there we have a file called static Spring factories, and this Spring.factories in Spring, you may know that in Spring Framework, I don't know, 2.5, something like that, we introduced a service loader mechanism based on the equivalent mechanism in Java 6, right? So Spring.factories Here we go. Spring.factories, it's keys and values, right? The keys are usually type names, and then there's values. And so you can, the infrastructure inside of Spring says, hey, given this type, give me a list of classes that correspond to that, right? Properties and blah, blah, blah. And so we use this kind of stuff all the time. We use it for auto configuration, for listeners, for all that kind of stuff. One thing we could do, one thing that we have done for several, for half a year now, since we've been doing more recent Spring native releases, is to turn that lookup into this Java class. We actually create a Java class for you at compile time, so that basically when Spring Boot starts up in a native context, it just looks at this class instead of having to reload these files into memory, which is a resource which has to have a hint, and then parse them and do reflection on them. All that stuff we minimize or eliminate as much as possible. So here's the Java version of that type, and it's just created for you automatically. Everything still works. It's just that behind the scenes, we're creating this. That's old news, but I think that's a nice thing to know about. The other thing that we did is that we actually transpile all of your application beans into functional configuration. So here's a bean provider method. It's a method that returns a value, an object that we register in the application context for you. This object can have whatever lifecycle you want. It's a regular Spring bean, right? It has all the same qualities as any other way of registering it. And we also find things that have been created like this, my type, whatever, right, with stereotype marker annotations. And we create all those, we find all those things that require us to do reflection. Like, for example, in order to find this method on this type, Spring would have to do a little bit of reflection on customer's application, and then find this method, and then find the return value and all that stuff. So instead of doing any of that at runtime, we do all of that at build time, and we create functional registrations. Basically, there's a mechanism that was introduced in Spring Framework 5 in 2017, where you can programmatically register objects with the application context. So here's a very trivial example. We're saying, create a bean definition registrar with the name routes with this resolvable type. Here's the type and the generic parameter for that type with this factory method, right? The factory method is the thing that we're calling to, so given this class, blah, 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 right? Here's a supplier that creates an instance of it, and so on, right? So we're actually creating that for you automatically. We also have the ability to plug in hints that go above and beyond what you see here. And we'll talk about that in a second as well. Those hints are why this works, right? We can actually look at these types and say, hey, we know this is a Spring Data repository, right? The customer repository is a Spring Data repository. And therefore, we're going to have to make sure that GraalVM knows to allow, proxies and reflection on those things, etc. Okay, so that's just done automatically. And that's one of the reasons why these compilations are now so quick, right? I can get a typical application up in a few minutes. A very big application, a monolith, will take obviously a bit longer, but hopefully this is pretty typical of what you experience when you work with a Spring Boot and Spring Native application. Okay, so we've looked at the AOT plugin, we looked at Spring Native, and we looked at just building a traditional typical application. And you can see that things that are in the resources folder, like in source main resources, those will automatically get picked up, right? Those are automatically being loaded. I didn't have to do anything special to make that work. But if you have some other thing that you're loading from the class path from some other jar, for example, and there's not already an accommodation that's been made for that, then you need to add a hint, and we'll talk about that in just a second. Okay, so this is pretty typical, hopefully. That said, let's look at some other workloads, okay? So I've got here, I just did a video on Spring Native. So Spring Native, Spring Tips. That's not this one. Where's the newest one? This one here, 5 days ago. And this is this video is a video on Spring Native 001, and there's code for this. So github.com spring-tips and repositories and Spring Native 011x. Okay, so this has some of the code that we're going to look at here. Just for reference, I'm not going to type out all these projects right now. Whoops. Sublime. Okay, so we got 3 examples here. We got the reactive one, which is basically identical to the one I just showed you. Let's see what this one looks like. Oops, that's a little large. Okay, there we go. So we got a record, we got a repository. And instead of me using a SQL file, I programmatically register the objects, but same result. Schema, blah, blah, blah. Okay, we've got that one. We've got a Spring Batch application because, why not? Spring Batch is a very common use case. And basically we have a job, and the job has a single step, and it talks to a SQL data store, which is H2 in this case. Pretty trivial, but basically you can see all the important moving parts of a Spring Batch application are there. And then we've got a traditional application, right? And this traditional application is more typical, I think, of a lot of the workloads from yesteryear, things that use Hibernate and JPA, right? These things that are certainly very popular and so on. So this is a repository. It's using JPA, so I can't use the nice svelte ergonomic records from the newer Java releases. It's got a repository using the JPA repository. And this is using Apache Tomcat and the Servlet API instead of a non-blocking reactive web runtime like Netty. So, okay, we've got all those kinds of applications. Let's look at the numbers here. First, we can look at the reactive one. Well, actually, we already did that. We already saw that it takes, so many seconds and so much time. So let's go to the batch one. This is a target. I've already pre-compiled these because I didn't want to sit here waiting for all that to finish. So that one starts up. You can see, let me see, 68 thousandths of a millisecond. So basically, of a second, 68 milliseconds. So basically on par with a reactive application. Yeah. So this one is using blocking JDBC, right? It's doing blocking JDBC and SQL data access, but still not very huge, not very problematic. And you can see when the application starts up, it actually runs the job too. So it creates the job, stores the metadata in the SQL database, runs it, gets the result printed out, finishes, and then shuts down afterwards. Okay, so that's fine. Let's run that again though, and take a look at its memory. Okay, so this is doing a bit more at runtime. So ps-aux grep batch. Okay, batch. Here it is. Bin rss dot voila. Okay, so that's 83 megs of RAM. Okay, so it's a bit more RAM, but still not bad. Again, your typical JRE application will take 500 megs of RAM. So we're still talking 5x or more reduction in memory footprint. That's a big deal. You can scale down your Kubernetes cluster 5 times or add 5 times more apps to your cluster in the same vein without having to change a line of code, which is a big deal. Okay, so that's fine. Now traditional. This is not, could we do better? Yes, use reactive. Okay, what is that? That's 172 milliseconds. Let's see what the memory is on that one. So ps-aux grep traditional. All right, here we go. Bin rss, blah, blah, blah. And that's 127 megs of RAM. So nearly double the amount of RAM and certainly double the amount of time, right? Just by using JPA and so on. So, sometimes these things take longer than you'd like, but it still works. You can still get this stuff working. When you go to start.spring.io, mind you, if you go here and you choose JPA, this is important, it'll pre-configure, you need native as well. It'll pre-configure the Hibernate Enhanced Maven plugin. So it'll actually, Hibernate has some things it needs done to make Hibernate entities work in a GraalVM context. So that's what this does for you. That's above and beyond what Spring Native has to do. Okay, so we've looked at some numbers. We looked at some basic applications. Hopefully this will just work for you out of the box, right? That's the goal, certainly. But sometimes it won't. Sometimes there's going to be a gap between what Spring is doing and what Spring Native can figure out. And you can see what we're trying to do. We're actually, we write functional configuration versions of all of the auto configuration on the class path and of all your beans. So if you're doing something straightforward, like creating a bean or returning it, or creating a component or a controller or a service or whatever, should be fine, right? And we even have support for a lot of the common use cases, like if you have @transactional or if you have whatever. I mean, Spring Data repositories, which are just interfaces and therefore require proxies and reflection, all that kind of stuff should work in the common case. And you can see, you can see that it does, but there may be gaps. There certainly will be gaps, at least in the beginning, right? Our goal is to do this research now, to figure out all this stuff now. We've been working on Spring Native since, like I said, early last year in earnest. I think we even had some stuff the year before in 2019, but the goal is to get this to a good enough position or state that it can then become part of Spring Framework 6, which is due next year, and Spring Boot 3, which will follow it pretty shortly thereafter. So the goal here is to have built-in support. I was about to say native support. I was about to say native support, but then I said, no, don't say that. The goal is to have built-in support for native applications in Spring Framework 6 next year. You can use Spring Native. We encourage people to use Spring Native. It's not yet out in the general release Maven repositories, in the same way that the GraalVM native image compiler is not yet already included in GraalVM, right? Would you go to production with it today? I mean, yeah, I don't know. If it works for you, please do. It's as good as GraalVM is, you know, like it's definitely getting very, very good. So check it out. Now, that said, like I said, there's going to be some gaps. So let's talk about what you can do to plug those gaps, you know? Okay, so I'm going to go back here and I'm just going to add Spring Native, nothing else. I use Java 17. Let's call this extensibility, okay? We'll hit generate. And we'll open this up in the IDE, UAO extensibility.zip. Okay, so the first line of defense, the first recourse that you have is if you want to do something that Spring doesn't know about. Let's say you're like, okay, so let's say I have an application runner and for some reason I am just bound and determined to do reflection in this. Okay, so I've decided that I've got this class, you know, what am I doing? Record customer, whatever, integer ID, string name, okay? And I just absolutely want to reflect on that type, okay? That kind of thing, right? This might actually even work. Sometimes, here's the most frustrating part. Things like this sometimes work because GraalVM looks at the fact that you're using the class literal, the dot class literal, and keeps it. Where you get into trouble is when you do things like class.forename and the name of the string of equals, you know, com.example plus, you know, true, you know, whatever else this, right, plus dot customer, right? So where you add a little bit of indirection, where you make it not exactly clear how, you know, what the final value will be. And then I want to say name of class. So here I'm actually loading an instance of the class type. And maybe this won't work. Actually, it might. You know, GraalVM is getting increasingly smart. That's the problem, is that in theory, it should just be simple. Whenever you do anything with reflection, you need to give it a hint about what you're doing. But sometimes it works, and it's very confusing that it does. So my advice is just whenever you do anything with .class, think about problems, right? Think about the possibility that this won't necessarily work. So when you've got a class, you know, you can say a class dot get constructors dot 0 dot new instance and I and the, you know, the values will be 1 and Matt and whatever. Okay, so I have an instance of an object there, and I don't have to cast it to customer. It's not reachable there. So this whole thing would probably run afoul of GraalVM's runtime, right? So you have to provide a type hint. You can provide JSON files, right? GraalVM supports JSON files that are of the form metainf /native-image / and then the group ID, artifact ID, and then config files like reflect-config.json. But we provide hints, these annotations you can use. So here's a type hint, and the type would be, for example, customer.class, right? Customer.class, and the type of access that you would like to allow is, you know, usually type hint auto detect is fine, but you know, you might want to be very specific. In fact, you are encouraged to be very specific about the granular levels of reflection, because we have to add, you know, GraalVM it creates a shim and it stuffs that into the memory of the native image. And so it necessarily balloons the application's runtime footprint and startup time. So you can be as frugal as you want by giving it just the minimum it needs to do what it needs to do. So you can say type access is declared, or maybe auto detect or whatever, right? Okay, so that's one option, is these type hints. What about if you want to load a resource from a jar? Well, you can say, hey, I'm going to load my.ico, right? Who knows what jar that's in, but it's going to be a thing I'm going to load. So you might want to have a resource hint. If it's a resource bundle, then you have to specify true, and then, you know, it's a different thing, of course, but if it's by default, it's false. What if you're doing serialization, or sorry, proxies? Well, in Spring, we have two different types of proxies, right? We have proxies like, so here, let me show you an example here. Let's say I wanted to create interface customer service, okay? And, you know, I wanted to say void, you know, refund, I don't know, whatever, okay? Just some method there. And I want to create an instance of that. For some reason, I feel like being fancy and doing it the completely wrong way. And so I want to say proxy factory dot get proxy customer service dot class new method interceptor. And now if invocation dot get method dot get name equals refund, then I want to, you asked for a refund. Too bad, right? Okay, so there you go. Otherwise return null. So now I've created a JDK proxy here of type customer service. Well, of course, Spring doesn't know that, especially if you type this down to just object, right? And so you have to register a proxy hint. You have to say, hey, this is a proxy that's being used, that's using the JDK proxy mechanism, so customer service.class. But the thing is, behind the scenes, if you actually enumerate this type, let's see here, return, so we can say customer service, okay? If I go here, if I get that instance, I say refund.getClass.getInterfaces for var see this system out, the interface is c.getName, good, okay? So run that, let's see what that gives me at runtime. And then also we can, hello. Oh yeah, that no longer applies. Let's also exercise it to make sure it works. So refund, goodie. Okay, so you can see it printed out that, so that's worked just fine. But we actually have more than one interface there. So you have to be aware of that. There's actually, usually when you create a Spring proxy, using the proxy factory bean, there's more than one interface present. Now, are you likely to write this kind of cute, you know, overly clever code? Probably not. But is a framework that you're using likely to do something like that? Probably, right? So you got to just be aware of that, and it's easy enough to fix, but you do have to be aware of it. Okay. So that's the rewritten, you know, correct version of that declaration. There's also something called an AOT proxy. So Spring has the ability to create proxies for concrete classes, not just interfaces, as is supported by the JDK. These concrete classes, we do that by subclassing your type at proxy time and creating a subclass, right, dynamically. And then we call super, and, you know, we wrap the proxy around the invocations there. We say call proxy, super, call end of proxy, right? And this is we support this through CGlib. It's been in Spring Framework since Spring Framework 3 in 2009. We call those AOT proxies, right? And it's the same basic arrangement. You say interfaces or target class. So you can have an AOT proxy with a concrete class and several interfaces that get implemented, right? But same basic idea. In this case, the example I showed you is not using, there's no concrete type. It's an interface with other interfaces. So nothing special there. And that works just fine. So, okay, a lot of hints, right? Resource hints, proxy hints, native hints. If you want to specify options, right? GraalVM is very, very frugal with the things that it allows. Like, for example, you know, there's not even a guarantee necessarily that your GraalVM compiler will let you use HTTPS by default. You actually have to pass in an option. And there's a lot of different options that you can pass in. If ever you wanted to know where to pass those options in, put it in native hint options here, and that'll get fed into the compiler. You can actually see the results of that here. Target, well, no, over here. Let's go back to this one. Resources, meta-inf, native image property. So here it says enable HTTPS. Somewhere in the hint stack, you know, and all these different hints that we provide, we added this for you. You're welcome. Like the fact that that wasn't there by default, GraalVM is a little awkward, right? So that kind of stuff, right? That gets fed in. If you put it here, that'll be, or if you put something that isn't already there, if you put something that isn't already in this list, then it'll get contributed for you. Native hint is an umbrella annotation, actually. You can put all these other annotations inside of this. So JDK proxy hints, etc. Okay, very good. So there's my very, very, very basic arrangement. You can also have a trigger, and you can say, I want this hint to apply only if this class is here and it's reachable. So I can say, let's say WebFlux auto configuration, for example, right? And so all of these hints, the options, all that stuff won't get run if this type isn't reachable, right? That's very, very powerful because now you can dynamically contribute hints. And maybe that's enough. Maybe you're done, maybe you've got this one cute proxy thing and you don't really want to go any further than just registering a little hint, and that's fine. But you can also package this stuff up and make it reusable for other people in your organization or for the larger community. And we do that through a number of different SPIs that you can use to provide this kind of stuff. So let's create a new package here. I'm just going to call it nativex, okay? And here, I'm going to create a my native configuration, okay? This is going to need a type that's not available in the Spring native library that's on the class path, but in the Spring AOT library, okay? Now, it used to be that this had to be a separate dependency that lived outside of your jar. It was something that was added to the class path of the Maven plugin, the Spring AOT Maven plugin itself, as opposed to your application's dependencies, right? But now they're all one and the same. So you just say, I want to add hints, and you can compute hints here. You can say, okay, I've got a pointer to the registry. I can say registry.proxy.jni options resources. Maybe you just have something that requires you to do some sort of dynamic thing and want to programmatically register one of those hints. You can do so using the registry, right? This is one option. Usually these days, I find I don't actually have to override that method, but if you register a bean of this type, so let's say I put this hint here, right? You can put hints here. You can stack your annotations there. Let's see what's the wrong one. Oh, that goes up here, so it's public. Okay. Now this is a package private type. Keep in mind that if it's package private, you can always use type names, right? But it can't be both. You have to do type names or types because otherwise it wouldn't know which goes in which order, right? So type names, you would just say blah blah blah. As a string, etc. Okay. Okay. So basic proxies, good stuff. You can put hints up here like that. Let's see. Close this. Good. All right. Now I've got this is a basic callback. There's another one that's more useful, I think, these days, which is my native bean. This is a bit of a mouthful, so write this one down. Bean factory native configuration processor. Okay. And this one implements bean factory native configuration processor. The callback is this. See, what we do in order to figure out what types are needed for your class is that we invoke these. We actually start up an application context that has all the bean definitions inside of it. And we actually, at compile time, we start up the application. We don't start it. We create the context as though you had started it, right? So all the beans that you have in your application, they get contributed to the context, but we don't actually invoke we don't actually create the objects. We don't start the lifecycle methods, etc. But we have a context that has a bunch of objects that have the same shape as what you will have at runtime. And so it's in that way that we're able to say, hey, we know that at runtime, this Spring application context is going to have these following 5 beans that have the following shape. And we know that these beans that implement at Spring Data repository are Spring Data repositories. So we're going to contribute some custom hints. And then way we can do that is by using this very convenient callback interface, bean factory native configuration processor. And here you want to get bean names, right? Make sure you stick with the names. Don't call beans. Use the names because you want to get the names and then get the bean definition. So maybe I can say, get bean names for annotation, whatever. I don't know. Let's just find an example here. Service. Okay, that's an annotation. Okay, so here I'm saying give me all Spring beans that have this annotation on them. Give me their names for var bean name, bean names for annotation, bean factory dot get bean definition. Okay, given that bean name. So now you have a pointer to the meta model that Spring uses to describe how objects are registered in the context. And there you can do things like poke at its constructor arguments, its parameters, its fields, what dependencies it has, what annotations it has, the class name itself. So for example, this one is the class, right? You can actually say class, whatever, bean class equals class dot for name, that kind of stuff. You can do all that at compile time. And the benefit of this, of course, is that you can register hints, right? You have access to that same registry that we looked at earlier. So you can say registry.reflection.forType bean class, and you can say I want to give it access to, let's say we saw declared constructors and all that kind of stuff. Well, auto detect, and then I can build it, right? So here you're able to programmatically register all those annotations that you saw earlier. All the same effect is that you can register the hints for all those things using this callback interface. The only thing you have to do is to create a meta info directory. And this is the same mechanism, the same service loader, Spring.Factories, that Spring Boot itself uses for its auto configuration, right? So bean factory native configuration processor, good guess there, Intellij, legit impressed. Extensibility dot nativex, my bean factory native configuration processor, etc. So there's that. There's my callback. That's how it's registered. Spring Native will now find that. So let's go ahead and prove it. Let's by writing it out. So found the following bean with @service, and the bean is called bean class name. Okay. Now, of course, do I need to do this? No, because probably Spring has already found my @service. That is by definition a stereotype annotation. But any arbitrary annotation is I guess what I'm trying to say. So where do I go here? This is an interface. Let's make this a type @service. Okay, void, refund, whatever. Okay, so now run this. Terminal, Maven, Spring AOT generate clean package. Okay, so we're gonna just do the AOT transformations just to see what it does. Okay. Found the following being with service, right? So there it is, customer service. So this is how we can programmatically augment the information that GraalVM has about our components. Do you have to worry about this most of the time? No, but it's very useful to know that it's there. So I've been working with Matt and with Ronald Heiser and on the Job Runner project, and I've been working with Matt and I worked on the Okta Spring Boot starter at some point. I'm not sure where that is right now. Maybe Matt can fill us in. We worked on a bunch of projects. My life has just been going around helping different projects to build these hints, and that way they just work out of the box for you, right? That's my time, friends. We finally, the real stars here. Matt, thanks for taking over for me, my friend. I got to run, as you know, to the people who are listening. Thanks for hanging out. If you have questions, ask Matt, and if he doesn't know, maybe ask me. But I don't usually know. If he doesn't know, then I certainly won't. But I can try and help.
Josh, thank you very much. It's your presentations are awesome as always.
Thanks to Matt, one of my heroes. Hey, Matt, thank you again. Thanks everybody. Have a great day. I'm sorry I got to run personal. I got to get to a funeral. Bye-bye.
All right. Take care. Take care, Josh. Thank you.
Well, I'll take it from here. Hopefully you can see my screen just fine. So what Josh and I did is over the last, I guess, starting on Monday is tried to make Spring Native work with JHipster. And we did this back in September as well. And at that time, it was, I think it was 7.2 of JHipster and Spring Boot 2.5.5. So this is all in the Spring Native examples, which is under my repo on GitHub. If we were to go to github.com, and Raible, nope, close. Spring Native examples. I did a release today with 0.1, which is everything we did for the San Francisco Jug back in September. And so what I did is I flew out to see Josh in San Francisco, and we spent like 2 or 3 days hacking on this and got it all working. And so we basically figured, well, we could do most of that with Spring Boot 2.6 and Spring Native 0.11. Well, one of the problems is that that Spring Boot 2.6 is not quite integrated into JHipster yet. So everything that I'm going to show you today is actually on various branches where we're upgrading JHipster to Spring Boot 2.6. And we did run into some snags, but we got most things working. So basically I have this README that I will merged the pull request. If I was to go back to that repo, there is a pull request with everything we've been working on this week. And we basically created 5 different apps. So we started out with Spring Native WebFlux. And the reason we did that is we didn't want a database. We just wanted no client. We just wanted WebFlux. And so, what would it take in a JHipster app to get that working? And then we went from there to trying to get it working with Spring MVC. And the reason for using WebFlux first was just Josh had the most experience with Spring Native there. And so we figured, since he knew it, we could iterate on that faster. And then we started getting into the harder stuff, which is adding in Angular as a, UI in a JHipster app. Still no database. So, these were probably the hardest to get working originally back in September. And then in the last, couple days, those first 2 were pretty easy to get working. I was able to get them both working in about an hour based on previous knowledge. The Angular WebFlux one stumped me for a day, like a whole day. And then, I met with Josh and we worked on it. And then he actually brought a Spring security team member in and we worked on it. And after 2 hours, we found that we needed to change 1 line of code and we got it all working. So there's weird things like that, it was actually like a thing that worked fine on the JVM, but in native mode, it worked different. So I'll touch on that when we get to it. And then we wanted to get actually talking to a database working. And so all these examples actually talk to Keycloak or they talk to Okta or any OpenID Connect provider. And so we are making a call out to a server, when the app starts up or when it needs authentication. So there is, those things in the mix. So Postgres WebFlux and then Postgres MVC. So, we kind of stepped up and that's how we'd recommend you do it. If you're going to try to integrate this into an app is start with something small. And even when we got into the Angular WebFlux fiasco, we ended up creating a really small sample that had like 2 classes in it and trying to get that working instead of, dealing with long build times that take 5 or 6 minutes. So these are just the steps that you'll need to, add Spring Native to a JHipster app. So I am using the OAuth authentication in all these because I helped write it and I know it the best. So there's also JWT and session-based authentication. So I expect that those would work just fine. And maybe there isn't as many, modifications that you need to make. So just like Josh said, if you go to start.spring.io, the first thing is just adding those Spring releases. Since it is an experimental project, you can't get it from the main Maven repo. And then this Spring Native version, just specifying that. And then if you're using WebFlux, we found this one, which, oh man, I don't know how we found it last time, but it took us a while. But there's a dependency that's bringing in boring SSL for some reason for Netty. Maybe it's because we allow you to run with a TLS profile and have SSL locally or TLS when you're starting up. So commenting that out got past this error. So hopefully if you ever encounter that error and Google for it, you'll come on this document. And then you're just adding the Spring Native dependency. So, start.spring.io, you can get all that information from there. This is the same thing Josh did, just showing that. And then the native profile as well down here. So nothing's really different as far as integrating native. And I think, at some point once things kind of stabilize, we should be able to write a JHipster blueprint or module, basically that will add this stuff for you. And when Spring 6 comes out and Spring Boot 3, you won't need any of this because it's going to be like baked into the framework by itself. So the first thing I ran into was actually with Spring MVC and it was Makito. So the error I have down here at the bottom was code should not be empty. And so you're like, what the heck? And so I found someone that actually had already reported this, right? He's using a snapshot and I was like, what's going on here? And so I commented on it and I said, hey, I encountered this as well. And what's going on? And Mr. Stefan there looked at my project and was like, you're using Makito. You can't use Makito. And so I removed Makito and any tests that reference it, right? Because once you exclude it as a dependency, then all your tests are going to fail to compile. So deleting the tests and deleting Makito or excluding Makito solved it. But then what I noticed today was like, why is it necessary for Spring MVC but not WebFlux? So open question there. You can follow that issue if you're interested in the outcome. But that was kind of strange for me to be like, what? Why? What? If it's invoking the application context and doing that all at compile time, why is it fine for WebFlux and not Spring MVC? So you're just excluding this from the Spring Boot starter test there. And then here's all the JHipster tests you have to delete. So I realize like in a JHipster app, if you're using Spring MVC and you're looking at Spring Native, this is probably the last thing you want to do, right? Like remove Mockito, delete all your tests. So that's why this stuff is, very experimental at this point. Logback, the XML version is not supported. So that's another thing that you won't get until runtime, I think. So you have to delete that Spring logback, and then you can use configuration files to kind of tune that. There is also in Spring Native's documentation a how-to that shows you how to configure it programmatically, like with Java code. So if you do want to have, your logging tuned up nicely, then make sure and do that. We did find that we use Undertow by default in JHipster, and that didn't quite work. And so we did have to use Tomcat. I saw in the documentation that WebSockets in Spring Native support like Netty and Jetty and Tomcat and Undertow. So maybe it's just the regular MVC stuff. But that was one thing. And then there's this web configurer. Let me just pull that up to show you how that looks. Where we did have to comment out something. And it's not that important because in a JHipster app, it's really just for configuring things when you're running it with MVN like Spring Boot Run. So it's right in here, isn't it? Web. Let me make sure I got the right class, web configurer. Oh, we're in Spring MVC. So this is the Postgres MVC. I can just search for it here. And so, yeah, halfway down here, it's got this customized. So when running in an IDE or with MVN Spring Boot Run, it sets the location of the static web app set. So that causes an error, and removing it or commenting out like fixes the problem. So that was one thing that that you do kind of get a message that kind of indicates that. So that did help. And then you'll have to update your main app.java to add hints for Micrometer and Spring Security. This Spring Security one is the one that we basically spent hours on in the last couple of days. These actually come across and says like class not found. So when you're running the app, it happens at runtime. It kind of is an indicator that you need to add them, and that one's not too hard to figure out. But this one was hard because what was happening is it was actually redirecting to like Keycloak to actually log in, and then when it came back, it would give a 404. And so that JW decoder just wasn't getting invoked. And if you were to go to the Spring Native project now and look at the issues, Josh entered it yesterday when we found it. That's right here. And then there's one pull request that fixes it. So we've already made some progress there. And then Spring Docs, we recently switched from using Spring Fox to generate the Swagger information on the back end to using Spring Docs. And so they have a native dependency that you can use. You just add that to your regular dependencies, and then your Swagger, UI and all that will work. Liquidbase is not supported, but there's a pull request here that basically has a draft of, GraalVM support. You can see it's on July 26th there. And if you're to look in here, there's basically two files, a reflect config file, and then a resource config that just specifies all the class names that Liquidbase will use. And they use a lot of reflection. So you put those into your source main resources, meta-inf native image Liquidbase directory, and then add these type hints, and Liquidbase works. So when Josh and I first did this back in September, Liquidbase actually didn't work, and all the issues we found were like, it doesn't work, sorry. And so we were pretty excited when we actually got all this working with Liquidbase, and it works in the demos that I'll show you today. The other thing is the Hibernate build time bytecode enhancement that Josh mentioned, where, if you're using Gradle, it shows you how to do it there. If you're using Maven, it shows you how to do it here. So you just add that next to your Maven AOT plugin. But then this was, a weird one for us. We did get these as error messages, but we had to add the JDK proxy hint. Now you'll notice Josh did it with JPA and everything worked fine. And in this example, we're just using JPA in a, JHipster Spring Boot application, but we had to add JDK proxy hint. So not sure why, but we did add those and it did fix it. And then the other thing I noticed was, let's look at this one here. There's in the Postgres MVC, there's a domain class here, abstract auditing entity. You'll see that's a mapped superclass in JPA, and it's got an entity listener, auditing entity listener, and it basically invokes these created by, created date, and populates those methods. And so there's this user that extends it. And the error that I was seeing yesterday was that it wasn't populating like the created by and created date and all that. And by moving this entity listener onto the class itself, that works. So I did mention that to the Spring Native team. Haven't really heard back, but that is a thing that I saw, and adding it directly to the class fixed it instead of the parent class. And then this was a new one for me here, the request parameter. So by default, JHipster didn't have this name and it didn't have this. So it's just got path variable long ID. And for the name here, basically adding that fixed a problem. So there was an error from, Spring Native saying, hey, I can't find this. And it would happen at runtime, like you're editing a record. And it would just, you get an error in the console and an error on the screen. And by adding those names, it kind of added that. So there's a blog post that I used to figure that out. So that was great that that guy actually documented that. And then for logout to work was another one. So I had expression ID token on this authenticated principal. So it's authentication principal and then an expression ID token, and that would automatically suck it out and put it into an OIDC ID token object. And there's just an error. So something with Spring expression language wasn't working in Spring Native. And by changing it just to an OIDC user and using the ID token there, that fixed it. And then this was the one that took us, a couple hours yesterday is we have a SPA web filter. So if I was to open up that class, it's an Angular WebFlux here. And all it does is basically it forwards anything that's not handled by the backend to the front end. So if it's got any dot files or anything, it forwards it to index.html. It's just basically how we're doing SPA stuff when packaged in a WebFlux application. And we had a component annotation on here, right? So this would get invoked. But the strange thing is in our security configuration, we're adding it, right, manually. So on the JVM, this works great. And it doesn't actually, put this before anything. But by having that component in there when it's native, it actually has that web filter first. So it never got to our authentication. So basically we load up, JHipster, you click on sign in and it'll give you a 404 because it would hit this filter instead of hitting, Spring security on the back end. So that was a tough one to figure out, but a JHipster bug because we removed that and it still works because we're programmatically adding that. And then Spring WebFlux with R2DBC, we haven't figured out that one yet. So there's this ongoing issue where we're upgrading Spring's reactive repository implementation to be better and to use some new features in R2DBC. There's simple R2DBC repository. And if you look here, this is there I'm seeing, right? No suitable constructor found with these various classes. So I tried refactoring it, didn't work, but there's another guy that's like looking into it now. So you can follow this issue if you want to, see how we solve that. But, it's got most tests are passing, and it's part of our bigger Spring 2.6 implementation. So if you were to go here and scroll down to Spring Boot 2.6, you can see that not all the tests are passing. We've got 23 files that are changed, but we're making progress. So we've been working on that since October, and we're getting closer every day. So I think if Spring Boot 2.6 was fully integrated in JHipster, we probably wouldn't have these problems. But really, the only issue we found that wasn't known by Spring Native is the R2DBC and those simple R2DBC repositories. And then back here, metrics don't work because of some thread MX bean. Logs don't work. Configuration doesn't work. That's another option under the admin menu. And then H2 doesn't work because we actually start up an H2 server, so you can modify it from your browser and go to it. And we do that with profiles. So I could add a type hint for this, but it wouldn't actually compile because by default it's not in the class path. So those are just some JHipster issues, and now I'll show you the various examples here. So the first one is Spring Native WebFlux, right? That's the first thing we got working. So I've already compiled it to the target directory here, and I could run it with Keycloak, but you wouldn't really see anything. So I'm going to run this with Okta, and I've created an app on Okta with these settings in this okta.env file. So you can see there, we just override these three properties from Spring Security, and we're talking to Okta instead of Keycloak. And that will allow me to show you, that it actually works. So target, I think it's in here as JHipster. So we started up, it does a little bit of talking to, Okta to get things going. And, it starts up in a couple seconds. So normal JHipster app is probably, more like 10 or 15 seconds. So it's quite a savings there. And if we were to go here, well, there's nothing really there. And we're not authenticated. So if we were to pull up a terminal and use HTTP and go to like 8080 API account, we'll get a 401, right? We're not authorized. And then we could go to OIDC debugger, where I've already pre-configured an app and I can get an access token. So send that, get an access token back once I've signed in. And then I can put that into a token variable. And then I can use HTTP to hit it with that bearer token. And now you'll see stuff happens in the background and it's actually pulling up, data. So that's all working as far as just the basic API functionality. And then if we were to, cancel that one, we're not using a database yet, right? So if I use Docker PS, there's nothing running. If I was to do Spring Native, just MVC one, again, target and JHipster. That one's got some more logging. It's probably just because I didn't turn it down in those application, YAML files. So that would probably be much faster if I wasn't doing all that logging. And then, we could hit this one as well with that same bearer token. And that's all working. And that's because I set those variables doing source on that .env file, in this terminal. So that's that one. And then we have Angular WebFlux. That one's in target. ngFlux is the name. So that one didn't print out its time, but it's using WebFlux. So maybe that's something in there. And then we can actually open this one in a browser, right? So localhost 8080, click sign in. Since I'm already logged into Okta, it'll basically come back. And what I've seen is if you were to do this with Keycloak, it actually like visually happens like 3 to 5 times faster. When you click on that sign in, it like bam, all of a sudden it's there and then bam, right back. So you can tell like the native app is running faster. And so, we don't have any entities here. If we were to go to metrics, right, there'd be a JMX error in the background. So these are all the things I was talking about. The health checks, there isn't anything. So that one works. Configuration logs have issues. And I think even the Swagger stuff has some issues. And I think that's just because that's in progress as well. And then the sign out doesn't work, but I didn't fix it in this app. I fixed it in a different one. So, that's showing that the Angular app actually works. And then just to show you the other ones, we have Postgres Mvc. And so I will start a Postgres container here. Just put JH Postgres up as an alias I have for Docker Compose. So you can see what that looks like there. And then I can start this one, target, and I would need to start Keycloak normally. So if I were to open up a new terminal, right, then it wouldn't have those Okta settings. So if we went to Postgres MVC, then we could do JH Keycloak up and we could start it with target. What is it? Postgres MVC. Oh, so maybe Keycloak isn't up yet. Let's JH Keycloak up. And then, wow, it started real fast, right? Barely even noticed. And then we were to go to localhost 8080. What's going on here? Come on, you were working earlier. Let's try Docker PS just to make sure everything's up and running. I did update my Docker before this, so that could be my fault. Let's see, target. So there we go. It worked the second time. Open that up. And we can sign in. Redirects us to Keycloak. And now we're logged in and we can actually see our entities, right? We could add a new one, test. We'll add it to the admin user. And that's all working. And then we could log out because I fixed it in this one. So the last one was just the WebFlux R2 DBC. So Postgres WebFlux and target Postgres. It talks to a different database, but it won't even start anyway. So you'll see that's the error that I'm seeing. So that's really the only thing that we haven't been able to solve. And I think we will solve it in the next few days. But it just goes to show that, some of the stuff is definitely experimental and new, but what I'll do is I'll just go ahead and merge this PR right now. So let's see. And Raible, Spring Native examples, and then I'll get Josh to add his that he added earlier. So we'll just get this in there and then ready for review and merge it in. So it certainly is possible, to use Spring Native with JHipster, but part of the problem is we're still, upgrading to Spring Boot 2.6. So that's one of the biggest, problems we're experimenting with now. And there's also a Spring Boot starter that Okta has to integrate with Okta, and it's just a thin wrapper around Spring Security. So Spring Security and Spring Native works fine with Okta, but if you were to go here, we did find an issue which they haven't admitted is a problem. So it's right down environment post-processor implementation. So this is my coworker, Brian Demers, and he put this ticket in here and down at the bottom. In any case, I think we can try and fix this issue. So that's the only issue we've seen there. We spent a couple hours with Josh on Twitch back in June, like getting it all working. And so it's been like a real fun process for me because I'm learning stuff, right? And it's always fun when you're learning stuff. So I think Spring Native is worth looking into, especially, just on small projects to see how much it improves over time and just enjoy it that way. So if anyone has any questions, I'll take them now.
Yeah.
And I
Matt,
realize we're like broadcasting to YouTube, right? So we're like
Yes.
20 seconds delayed or whatever.
Yeah, we've been monitoring the chat over at YouTube, and also want to send a reminder that we did post the link for the form to enter your name and email address for the raffle for Intellij idea. I wanted to, I know Josh is not there, but I thought I'd ask you, Matt, the upcoming, it won't be till next year, the Spring Framework 6 and Spring Boot 3.
Yeah.
They're going to be overhauled, I think, to adopt modularity somewhat. We did have a Carsten Sills from, one of the Java editors at InfoQ put together a nice piece back in, I think it was October or something like that. I can share the link on that, but I don't know, what did you want to do? You had mentioned something about Spring Boot 3 and how that will change for this application. So I don't know if you wanted to say some words about those upcoming versions, which won't see till next year, I think.
Right. So they announced it at Spring 1, which was like end of August, early September. And they were basically saying in a very bold statement, right? Like, we're going to rewrite Spring. We're not really rewrite it, but we're going to baseline it on Java 17. Right. So it's the first framework to basically do that, because everyone else is like, yeah, we'll work on Java 8 and Java 11. Right. But they're like, no, Spring Framework 6 will only work on Java 17 and above. And part of their reasoning for that is because of the 6-month cadence that we're dealing with now, and them just saying that, by the time this is actually released, we're going to be on like Java 23 or something like that. Right. That's their statement. And they want to build a framework for the next 10 years. So it'll probably support like Java 17 through like Java 28 or something like that, right? And so they've had a really good track record of backwards compatibility, and I think they're just ready to get rid of some of that baggage and some of that tech debt and make it so it works similar to the other native frameworks you've seen, or the other, hot REST API frameworks, particularly Micronaut and Quarkus, which they do a lot of things at compile time, right? Using AOT like Spring Boot does here, but instead of using like runtime reflection and stuff, it all happens at compile time. So you pay in the compile phase, but then at runtime you're super fast. So I think they were very good at motivating Spring to adopt that mentality and use that going forward. So Spring 6, I think they're going for Q4 of next year, and then Spring Boot will follow typically a month or two after.
Yeah, I thought there were
And
going
then
to be some release candidate or milestone releases between now and, like, say, July or something like this.
Oh yeah, there always is, right? So if you were to follow the main Spring Framework repo or whatever, you'll see when releases come out.
Yeah, it's
And then I wanted to plug this user survey that we're doing for JHipster. So if you're using JHipster or considering it, go to jhipster.tech and fill out this developer survey, because we're using it to kind of shape the future of JHipster. And so right now you generate an app and you answer all these questions beforehand, and then it generates it. And we're actually exploring like a more modular setup where the first thing you might do is just JHipster init, and that like sets up, just a basic app that you could write a command line app with. And then JHipster Spring Boot would add Spring Boot to it. JHipster Maven would add Maven or Gradle. And so it's still, in the end, you could build the same sort of apps you build with the main JHipster that is in its current incarnation, but they want to make it easier to maintain as a whole for the project and make it more modular as well. So this modularity thing is catching on.
Oh yeah, absolutely. It's kind of funny since JDK9 came out, like 4 years ago?
Right.
So, then all of a sudden it's going to be a hot commodity. But
hey, Matt,
that's.
I also have another question, if you don't mind. This may be like
Sure.
a very, very basic question. So we all know that Spring Boot is already very easy to use. It can give us a lot of options, and we have like, what is the purpose of using JHipster? If we are already using Spring Boot, how would you sell it to your manager or something that we should use JHipster?
So the biggest thing I recommend is just start with prototyping with it. I was on a project back in 2013 or 14 when I was an independent consultant, and basically someone spun up something with Python using Django, and they were like, how can you do that in Java? And I was like, well, it's going to take me a while, right? And then I was like, I just heard of this JHipster thing. I'll try that. So, within an hour or two, I was able to replicate the same app with all the entities and have all that authentication and control built in. And so, it's a great learning tool for that. It's good for prototyping, see what you can do. And what we see on the project itself is we have a lot of Java users or Java developers that just don't want to write Angular or React. And I've spent, half of my career telling people just learn web development. I used to have a talk in the late 2000s that was like modern web development for Java developers, and it was basically just telling people go ahead and learn JavaScript, but a lot of Java developers don't want to. So we see a lot of usage there, and that's part of the reason for the survey too, is like, how are people actually using it, right? We've seen a lot of people just use it for microservices, so they won't even have a UI, and they'll generate multiple microservices with Spring Boot. And then we have the JHipster registry, which is a Eureka server that's already set up, and then they can all communicate with each other using like Spring Cloud Gateway. And so we've done a lot of the hard work. And for me, it's been very rewarding to be on the project and be on kind of the leading edge of Spring Boot and see what's happening, because if you listen to Josh, it's always roses, right? And then when you get down into it and try to migrate a project from Spring Boot 2.5 to 2.6, like, it ain't that easy, right? And and they've had great backwards compatibility, but like Josh says, a lot of times it's the ecosystem, right? The Mongoc that we're using to do MongoDB migrations, right, doesn't work with the latest release. Spring Fox hasn't been updated in a year, so it doesn't work with Spring Boot 2.6. Just like all those kind of things that you kind of find out there.
Wow, that's a good selling point. Thanks a lot.
Yeah, I don't see any other questions out there. Folks, here's your chance to do so.
Well, I help run the Denver Jug, and we get similar things where, if you're in person, you can just make people feel uncomfortable by being silent, right? But it doesn't really work when you're broadcasting over YouTube, and so you can't make people ask questions.
Exactly. Yeah. Yeah, I look forward to going back to the days of in-person talks. So that'll come. And,
yeah, I've been to a couple. I've done a conference in now I've done one in October, November, and December, and I've spoken in person. I mean, maybe there's only 5 people in the room, right? But
yeah,
it's been fun to do in person again.
Yeah, just to let folks know who are on this talk, the Garden State Java Group is going to remain virtual through the first quarter of next year, just because the winter time is here and all that, and who knows with these variants and whatnot. So we'll take a look as we move forward. We have our leadership meetings once a week, and, so that's where we are at the moment with that. So. Yeah, so let's see where we are. I got a couple of quick slides. In the meantime, let folks still register.
Right, because you got an Intellij giveaway, right?
Yes, absolutely. Okay. I don't know who's gonna do the raffle. This is the one thing we need to hammer
it.
down a little bit quickly.
Hey, Mike, I can do it.
Okay, awesome. All right, let me make sure I'm in the right
Minutes
tab
to,
here
get-
to take over.
Mike, give me a few minutes to get in gear here, okay?
Okay, yep, I got a couple of things I want to, talk about next, so I will share my screen now. And before Scott Selikoff gives me a hard time, I'll make sure. All right, there we go. I had to mention his name tonight, so. Okay, so I'm sharing. Okay, we're back to where we were. Okay. So, so first of all, thanks, Matt, and of course, Josh, for your awesome presentation tonight. Upcoming events. Well, there's not much going on because this is the holiday season. There was a couple of conferences that just ended. Jakarta 1 was last Tuesday. That was a 12-hour event. I'm proud of that one only because I was on the program committee again. So, and there was one that Neha had was on the programming committee, or she led a track on it, and I forget which one that was. But right now it's quiet.
That was JConf.
JConf, that's it. Jake. Okay.
JConf Dev. Yep.
Yes. But I think DevOps, is a call for papers is out there. So just, obviously, I'm sure information like that's going to be on Twitter. Well, upcoming meetings. So here's what we have. We have the first 2 months of 2022 all set. We got Billy Carando, who will talk about Java 18 and beyond. And I think the title is actually, it's Forward to Java 18 and Beyond. But with JDK 18 being released in March and the feature set frozen, this is like a perfect time to have a talk on that, to give you an idea what to expect in Java 18 next March. With the release of Microprofile 5, I encouraged Emily Zhang to give a talk on that. We are targeting a 12 p.m. Lunchtime because Emily is in the UK, and so I want to see how this works. So let's hope folks can attend during their lunch on February 8th. And we also Neha's been talking to Mary Gregleski, who a lot of you might know is the president of the Chicago user group. And so we haven't confirmed anything yet, but we have a tentative date of March for her talk. So just stay tuned for more info. Those of you on my list will obviously get the emails, and we'll have obviously any upcoming meetings on the website as we get them. So let's see. All right, so the ground rules, the biggest one is, if you won a prize in the last 6 months, we want to give that 6 months time window and give other folks a chance to, win a license to Intellij IDEA. So where are we with the raffle?
We're ready.
We're ready? Awesome.
Yeah. And the winner is Handra.
All right. Let me.
Neha, we have Handra's email address.
Is
I
Handra
was-
online there? If you can
I have her email address. I can send it off.
We're all set then. Okay.
Okay, awesome.
Congratulations.
Yeah, yes. You will hear from me. Most likely, I get the coupons from Intellij. So basically, it is a coupon that expires on a certain date, the coupon itself, but your Intellij IDEA license will be good for 1 full year whenever you register with that.
Nice. Congratulations.
I know, Matt, when you were with us back in July of 2019, you are a fellow craft beer enthusiast. So, this picture is very appropriate right here. So, but it is that time. It is 6:35 here in New Jersey. So, and it's what, 5:35 by you, Matt? So, or no,
4:35, so perfect happy hour time.
there you go. Perfect. Perfect. Are there any questions in the chat? Since I'm sharing, or I can stop sharing and take a look.
I don't see any questions, but yeah, I've joined Garden State Jug for almost a year now, and every time the beer picture comes up, Mike gets all sentimental.
Yeah. I do. I've been delivering the getting started with Jakarta, NoSQL, and MongoDB presentations. I think I've done it about 6 or 7 times since May, and I keep adding beers to the database. And new ones I've discovered. And when I present it to the Kansas City Jug, I search for beers out that way and put them in the database and that kind of thing. So it is a passion. So,
Nice.
but yeah, it's a great passion, I think, and just to try new things, especially if we go to a city for the first time.
Yeah, for sure.
I'll need to come out to Colorado one of these days. So.
Oh, we've got some good beers here. We'd love
Oh.
to have you. And I help run the Denver Jug, so I can get you a speaking slot even.
Awesome. Yeah, we'll have to work on that. So, but well, and if there are no questions, then I guess I'm gonna we'll leave the picture right there, and we look forward to seeing you folks next month. Have an excellent holiday. And a great new year. Thanks for supporting us all year. And we look forward to continuing, our quest here for, some great talks in the Java space. So, all right, Matt, again, thank you very much. And we'll talk to you folks soon.
All right, cheers.